which is all about scientific notation. We're going to talk about how to convert numbers to scientific notation and then do some adding, subtracting, multiplying, dividing as well. So starting with conversions, let's say we have a big number and we want to convert it to scientific notation. So let's say we have this number, which is 17,400,000. And we want to convert that to scientific notation. Just like the instructions say here, we're going to move that decimal point to the left until the coefficient is a number between 1 and 10. And then we'll count our number of jumps, or decimal places. So decimal point is here at the end, and I'm going to jump 1, 2, 3, 4, 5, 6, 7 spaces. Now, with my decimal point there, my number is 1.74. So just like it said in the instructions, a number between 1 and 10, right? So that's the number I have, and what did I say? I made 7 jumps to get there. So now we come down here to step 2. We write that coefficient number, 1.74, and then we write times 10 to the j power, where j is equal to the number of jumps. So times 10 to the 7th power, because that's how many jumps we had to get this number. So here's this very large number written in scientific notation. Okay. So we move to the left, count the jumps, make that your exponent. Okay. Now, for very small numbers, my binder's in the way, sorry. For very small numbers, it's the same principle, just the opposite. So let's say, I don't know, let's make up a really small number here, 0.0002305. How's that? So now we're going to do the same thing, start at the decimal point, except this time we're going to move to the right until the coefficient is a number between 1 and 10. So we'll go boom, 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 boom. All right, now my number is 2.305, and I made 1, 2, 3, 4 jumps to get there. Okay. So this time I'm going to write the coefficient, which is 2.305, times 10 to the negative j, where j is the number of jumps. So we have a really small number, we're going to have a negative exponent. So we go times 10 to the negative 4. So that's how we get really small numbers written in scientific notation. For scientists, scientific notation is good because you don't want to have to deal with numbers that are really, really big with a bunch of zeros or really, really small. This turns them into something that's a whole lot easier to do calculations with. As a quick note, your calculator might have an E. You might see a button that says E. That stands for exponent. So like this is 6.02 times 10 to the 23rd. So you don't have to put in that times 10. You just hit the E button. It also might look like this, 10 to the x power. So you would hit that button and then type in your exponent. So I might go 2.305. Then I'd either hit the E or this button, and then the negative 4. So you don't have to type in the times 10. These are the buttons that are used for exponents. Show me your calculator if you want me to point them out to you. All right, let's talk for a minute, about multiplying. I think that's what's on the back of your page about scientific notation, is doing some multiplication with scientific notation, correct? I have lost mine. Here it is. So if you flip that page over, it should have multiplying and dividing, scientific notation on the back. Okay, so there's some super specific rules for multiplying and dividing these. Basically, when we multiply, first you're going to multiply the coefficients. And then just like with any other exponents, like you learned in math class, you add the exponents, right? So we end up with something like this, 2.8 times 9.36. You're going to multiply those together, right? And then you're going to write times 10 to the 5 plus 8 power. You add those exponents, right? So when we do that, when we multiply those together, 2.8 times 9.36, we end up with 26.208. Then the exponents times 10 to the 13. Okay. First thing we notice is now this number is not in proper scientific notation because my number is not between 1 and 10. So we want to adjust it by moving the decimal place. So we start with our 26.208 times 10 to the 13th power. We're going to move this decimal point one place to the left. So then we have 2.6208 times 10. Because we moved it left, we want to increase our exponent. So times 10 to the 14th. So just multiply your numbers, add your exponents, and then adjust. Division, same principle, a little bit different. We're going to divide these numbers, though, and then subtract the exponents. So we end up with 1.75 divided by 5.23. Then our exponent times 10 to the 2 minus 5. Yes, it will be a negative number, right? So we divide these two numbers and we get 0.3346 times 10 to the negative third. 2 minus 5 is negative 3. And again, we notice that our number is not in proper scientific notation, right? So we need to adjust it. 0.3346 times 10 to the negative 3. We move our decimal place one jump to the right, and we end up with 3.346 times 10 to the negative 4. It gets more negative because we moved it to the right. If we'd moved it to the left, it would have gotten more positive. Here's some practice problems for you to try if you want to try them before you take the mastery check so you're sure you know what you're doing. Okay? I'll have a separate video that'll show the answers to the practice problems. All right, lastly, let's add and subtract with scientific notation here. Okay? Adding and subtracting scientific notation. Okay? So let's make up some numbers here. What if we had 7.52 times 10 to the negative 7 plus 5.12 times 10 to the negative 7. Okay? Excuse me. So these numbers have the same exponent, same power. So all we need to do is add the coefficients or subtract if it was subtraction. This happens to be addition. 2 plus 2 is 4. 5 plus 1 is 6. 7 plus 5 is 12. 12.64. Exponent stays the same, 10 to the negative 7. All right? And always check, because we are going to have to adjust this one. Move that decimal place 1 to the left. We get 1.264 times 10 to the negative 6. We added 1 because we moved to the left, right? We would make it more negative if we moved to the right. So 1.264 times 10 to the negative 6. Same exponent, just add and then adjust. Now, if they have different exponents, like let's look at this example. If we had 3.28 times 10 to the 5th plus 1.72 times 10 to the 8th. Okay, different exponents, we can't just add them together. Okay. We need to convert the number with the higher exponent so it has the same as this. So we're going to convert this to make it 10 to the 5th. The way we do that is we basically move our decimal point, because we want this number to be smaller, we move it to the right. 1, 2, 3 spaces. I picked 3 because 8 minus 5 is 3, right? So then we end up with 2.28 times 10 to the 5th plus 1720, because we moved that decimal point 3 places, times 10 to the 5th. Now I can add those numbers together. I'm going to put the bigger one on top, 1720, there's my decimal point, right, times 10 to the 5th. And then this one was 2.2, oops, I got to line up my decimals, sorry, that's basic third grade math. 2.28 times 10 to the 5th. And then we just add 1722.28 times 10 to the 5th. And of course we have to adjust to make it proper scientific notation. 1, 2, 3. So we got 1.7228 times 10. We moved it to the left 3, so we add 3. So times 10 to the 8th. So there's our number after we added with different exponents. Okay. One last little thing, if you're using a graphing calculator to do your work, which you can definitely do, before you add these numbers in scientific notation, make sure you got parentheses. So you should type it into your calculator something like this. 2.28 exponent 5, that's times 10 to the 5th, plus 1.72 exponent 8. Okay, make sure you got those parentheses. Or if your calculator is like this one, 2.28, then the button that says 10x and then a 5 plus 1.72, the button that says 10x and then the 8. Make sure you have those parentheses. Okay, so that is scientific notation. Do those practice problems before you take the quiz so you're sure that you know what you're doing.